Okay, so in this video we're looking at the SEC 2014 Leaving Cert Higher Level Maths Paper 1 Question 2, and it's a complex numbers question. So it says let z1 equals to 1 minus 2i. The complex number z1 is the root of the equation. Find the other two roots. Okay, so if I know z1 is a root, and I know that the coefficients and the constant at the end are real, so A, B, C, and D are elements of the real numbers, we can use the complex conjugate roots theorem. So I know z1 is a root, and I know the coefficients and the constants are real. I can use the complex conjugate roots theorem. That states that if z1 is equal to 1 minus 2i is a root, then z conjugate, which is 1 plus 2i, so I've just changed the sign of the real part I've just changed the sign of the imaginary part. So it was minus 2 and now it becomes plus 2. They are both roots. So if both of these are roots, then a follow-on is that both of these are factors. And remember, I'm getting the factors from going, I need a smaller pen. Z is equal to 3. This is an example. Would be a root. Then the factor would be z minus 3 would be the factor. So you can see the relationship here. I've subtracted 1 and added 2i to both sides to get this one, and I've subtracted 1 and subtracted 2i from both sides to get that factor. Okay, so brilliant, I know two factors now. Well, what do I know about roots? Roots satisfy the equation. So if I was to sub in 1 minus 2i in for the z's, it would mathematically make sense. It would satisfy the equation. But what do I know about factors? Factors divide in evenly. So if I have two factors here, both of them separately should divide in evenly. Or if I were to multiply them together, so z by z is z squared, z by minus 1 is minus z, z by minus 2i is minus 2iz, minus 1 by the second bracket is the whole second bracket, just the signs have changed, so it's minus z plus 1 plus 2i, and then the last one, 2i by the entire second bracket. 2i by z would be 2iz, 2i by minus 1 would be minus 2i, 2i by minus 2i is minus 4i squared. And at this point, lots of things cancel. The 2i, they cancel. What else cancels? The 2i's cancel. Z squared stays as z squared. Minus z and minus z is minus 2z. Plus 1 stays as the plus 1. And the minus 4i squared becomes plus 4 because I squared is minus 1. So if I multiply these two factors together, I get another factor. I can divide this factor in. Remember, a property of factors is that they divide in evenly. So I could divide this factor into this and get the third factor that I'm looking for. So we're doing long division then. Z squared by what is 2z cubed? That's 2z. So then we're multiplying the 2z by each of these three terms. So 2z by z squared. 2z by z squared is 2z cubed. 2z by minus 2z is minus 4z squared. 2z by 5 is plus 10z. And we need to change the signs all the way along. So this was a plus, change it to a minus. This was a minus, change it to a plus. This is a plus, change it to a minus. I'd highly recommend using a different color pen for that. Z squared plus 4z, minus 7z squared plus 4z squared is minus 3z squared. Plus 16z minus 10z is plus 6z. And we're bringing down the minus 15. Then ask yourself again, z squared by what is minus 3z squared? It's just minus 3, so you're going minus 3 by z squared is minus 3z squared. Minus 3 by minus 2z is minus by minus is plus, 2 by 3 is 6, and reverse z. Minus by plus is minus, 3 by 5 is 15. Change all the signs and it cancels down to 0. As it goes in evenly, as we get a 0 at the end, that means that this is a factor. Add 3 to both sides. Remember, we're basically saying that it's 2z minus 3 is equal to 0. So we're adding 3 to both sides and then dividing both sides by 2 to get z on its own. So this is the root. And it's really nice to finish it off by just writing out your answer. All 3 roots together then. Okay, the next part of the question. Let w equals to z1 by z1 conjugate. Well, I know what z1 is. It was in the question, the very start. I know what z1 conjugate is. We've already discussed this. You just need to change the sign of the imaginary part. Change the sign of the imaginary part. So it's going from minus 2i to plus 2i. And then w is the 2 of them multiplied together. And we can actually use our shortcut that we know, a plus bi by a minus bi ends up as a squared plus b squared. So a complex number by its conjugate just ends up as a squared plus b squared. So a is 1 and b is minus 2. And it doesn't matter if I use the plus 2 or the minus 2. If I had a minus 2 in this bracket, for example, minus 2 squared plus minus 2 squared is 4, so you just get 1 plus 4, which is 5, and it's 5 plus 0i. Then it asks us to plot each of them on an Argand diagram. So make sure you're just plotting a single point and putting letters beside it. So this was z1, z1 conjugate, and w. The next part of the question then asks us to find the angle. Find the measure of the acute angle z1, so this is z1w z1 conjugate w z1, so z1 conjugate w z1. So I'm looking for that big green angle there. I'm looking for theta, the green angle. But it's a lot easier if I were to just break this down and consider just the purple triangle here. How long is this? It's 2. And how long is this? The distance between 1 and 5 is 4. So I have a right angle triangle. And I could find this angle alpha by going opposite over adjacent. So tan alpha is equal to opposite over adjacent. Get the tan inverse of a half is 26.57. And that's this angle alpha. And as it's symmetrical, this is only working because it's symmetrical through the real axis. You can then just double it to find theta. And it says correct to the nearest degree. And we're getting theta is 53 degrees. Absolutely lovely question, to be honest. Everybody should definitely be able to do the part B1 and B2. And then I acknowledge the fact like part A is a little bit trickier. But a lot of it's just basic algebra as well. So once you slow down and don't make any silly mistakes, there's no reason that you shouldn't be able to do that kind of question. Hopefully you found the video helpful anyways.